As we discussed the slope of distance time graph, we got speed. Similarly, here two more points you need to learn. Those the area under the velocity time graph gives us displacement or distance. The area under the velocity time graph gives us displacement or distance. And the slope of velocity time graph gives us acceleration. Have a look. Because as we know that if you know the velocity and time, you can get the displacement. The displacement is equals to velocity into time. So the area under the graph of velocity time gives us the displacement. And the, the slope of velocity time graph. Slope means what formula? The change in y component to the change in x component. On y component velocity and x component time. So velocity by time you will get acceleration. The area under the graph of velocity time you will get a displacement. The slope of velocity time graph you will get acceleration. Velocity time graph of a uniform velocity body or uniform motion. What is uniform motion means? If the object is continuing its motion with a constant speed in a particular direction. Here I took one example. If you observe here, the time is going to change continuously from 0 to 6 seconds. But the velocity of the object is constant, 20 meter per second. And initially it is moving with the 20 meter per second and it is continuing with the same velocity 20 meter per second even the time is changing. So if you are representing this, then what shape you will get? Good. And initially the speed or the velocity of the object is 20 meter per second. At the 2 seconds also it is having the same velocity. And at the 4 seconds also it is having the same velocity. At the 6 seconds also there is a 20 meter per second. If you join these points, then you are getting a straight line parallel to the time axis. That means from velocity time graph, if you got the shape of a graph parallel to the x-axis or parallel to the time axis, that is the meaning of the object is moving with the constant velocity. There is no change in its velocity. Next, observe here how to get the displacement. As we discussed before, the distance or displacement from the velocity time graph you will get by observing the shape area under the graph. So here the shape of the graph is like, if you are observing the area, this is the area under the graph. It is obviously a rectangle shape. Then displacement you will get, displacement is equals to, what is the shape here? Rectangle. Then rectangle formula obviously L into B. That means displacement in this condition is equals to velocity into time. That is equals to how much here? 20 into time. L into B. That is 6, 120 meters. Like this you can find the displacement of the object also during the motion. Next, what you will get from the slope? For a uniform velocity body or uniform motion, what is slope then? Slope means what here? Change in y component by change in x component. What is on y axis here? Velocity. On the y axis, is there any change in it? No. That means there is no change in its velocity. That's why slope is 0. That means that the meaning of acceleration is 0. Yes, you can clearly observe here there is no change in its y component. Even the time is increasing, there is no change in its time component. That's why the change in velocity is 0. That is the reason acceleration is 0. From the velocity time graph, how to represent the uniform acceleration? We know that acceleration means rate of change in velocity. Then uniform acceleration means the change in velocity is constant in an equal interval of time. So I took similar example and see how to represent on a graph. The velocity of your object, if you observe initially at 0 meter per second, at 2 seconds it is 10 meter per second, and at 4 seconds it is 20 meter per second, at 6 seconds it is 30 meter per second. You can observe here there is an equal change in its velocity. That means here 10 meter per second during the 2 seconds. Here also the change in velocity is 10 meter per second. Here also the change in velocity is 10 meter per second within the equal interval of time. That means it is example of uniform acceleration. There is a change in its velocity that is constant with respect to the time. If you put it on graph, initially the object is having the velocity 0. At the 2 seconds its velocity is 10 meter per second. At the 4 seconds it's having the velocity of 20 meter per second. At the 6 seconds the velocity is 30 meter per second. If you join this, you are getting a straight line passing through horizon. Straight line passing through horizon. So the uniform acceleration of your body, if you represent on velocity and time, if you represent on velocity and time, you are getting a straight line passing through the horizon. And what you will get from the area of the graph? Again here, as we know, area, if you are observing up to the 6 seconds, the shape of the graph is like a triangle. Okay, so area means here the shape of the graph under this graph is in the shape of a triangle. That's the area formula of triangle formula you need to take, that is of BH. So here you will get a displacement if you are using the area of triangle formula, that is half into B value is a 6 and H is a 30. That means total 90 meters of displacement. And what you will get slope from this? Slope, we observed that the change in the y component. What is the change? What is there on the y axis here? Velocity. That's a change in velocity by change in x axis. That means d. Obviously, it's a acceleration. It's a acceleration. Take any 2 points on this. For example, this is 30 and this is between these two. You take it. I am taking this is a V1 and V2, and concern this time is T1, concern this time is a T2. Then you will get V2 minus V1 by T2 minus T1, which is equals to Vd is 30 meter per second minus V1 is 20 meter per second by time gap 6 minus 4, which is equals to 10 by 2. That meaning of 5 meter by second square. So you are getting a acceleration if you are finding the slope of this graph, and that acceleration is 5 meter by second square. So here 2 points you need to remember. Area under the graph of velocity time you will get a displacement, and the slope of velocity time graph you will get a acceleration.